Now, in today's lesson, we are going to be looking at kinetic theory of matter. This is a new topic. Now, what is the kinetic theory of matter talking about? Now, this is the postulate. The kinetic theory of matter postulates that the particles of matter are continually in motion and so possesses what? Kinetic energy. Now, let us explain the key points in this definition so we can understand the concept. Firstly, the first key points here are the what? The particles of what? Of matter. We all know that what matter is anything that has mass and occupies space, and everything around us are classified as matter. Take note that what matters consist of some building block. Matter consists of some building block. That is, matter consists of this building block I'm about to tell you now. It's just like I have a house and the foundation. Now, what are those foundation of matter? What are those things that come together to give us what? Matter. Those are what we call what? The particles. They are just three. We have the atoms, we have the molecules, and we have the what? And we have the ions. These are the building block of matter. That is, matter are composed of atoms, molecules, and ions. Now, all these three altogether are what we call what? The particles of matter. Now, they said they are continually in motion. What does that mean? It means that what all these particles listed here, they are never at rest. Are we together? They cannot what? They cannot be at rest. That is, they always move continuously. But their degree of movement are just different in different state of matter. Now, they said so possesses kinetic energy. Yes. Remember, the energy an object possess while it is in motion is what we call the kinetic energy. So it means that the particles of matter, atom, molecule, and ion, they are never at rest. They are always moving. They are continually in motion. As they are in motion, they always possess a kind of energy called kinetic energy. And you see this kinetic energy, it increases with increase in temperature. That is, the higher the temperature, the higher the kinetic energy. While the lower the temperature, the kinetic energy will be low. Now, we have three states of matter: the solid state, the liquid state, and the gaseous state. Now, the fundamental difference between the state of matter is their degree of movement. Now, take note that what look at particles in solid state. You can see that what the particles of solid are tightly packed. It means that what they have a large cohesive force between their particles. They have what a large cohesive force between their particles. And you can see that what the way the particles are tightly packed, it shows that what they are not compressible. I can say they are what they are incompressible. And take note, how do particles in solid states move? They move by a movement called vibrational movement. Are you together? Vibrational what? Or you can say what their motion is what? Vibrational what? Vibrational motion. That is, they move, but the movement is very restricted because of the structure. You can see that what they are tightly packed, so they just vibrate a little in a way that what you can never notice, and the particles can never move apart. Okay, they are always tightly packed. That is for solid state. So the second state is the liquid state. Yeah, they are also packed, but not as tight as that of solid. Particles in liquid can also move, but their movement is also restricted. Are we together? Good. So here also they are not compressible. Also, you cannot compress liquid, although they have spaces between their particles, but that state is really small. Are we together? Is very small. And because they still have some spaces between their particles, they undergo motion, like they can vibrate, and also specifically they can translate. So then they can exhibit translational motion. That is motion from one point to another. So if I just put liquid on a surface, what happens? It will spread and move and so on like that. But particles in gaseous state, they move by what we call random motion. Random what? Motion. That is, particles in gaseous state have no force of attraction between, like they are not tightly they are free to move about. Altogether, they are free to move about, and the way they move randomly, they strike each other and the walls of the container. So their motion is what we call zigzag motion. Okay, so those are the states of matter. So thanks for watching this section. Now let's look at the differences between the states of matter: the solid, the liquid, and the gas. Now pay attention. The first one is that solid have definite shape, liquid no definite shape, gas no definite shape. So let us explain this. Remember that solids, their particles are tightly packed. Therefore, they will have a definite shape because the particles are very close to each other and they are tightly packed with large cohesive force. Therefore, they will have a definite shape. Look at the pen I'm having here. You can see, oh, these have a definite shape the way it is like this. Why? Because the particles making up of this plastic, made up of like the plastic here, the particles that are making up this plastic, they are tightly packed together. So I'll surely have a definite shape. But liquid, no. The force of attraction between the particles of liquid is not as strong as that of solid. Therefore, they don't have a definite shape. In fact, liquid will take the shape of the container. Are we together? If you put liquid in a circular container, it will appear circular. In a triangular container, it will appear triangular, and so on like that. While gases, remember that gases have no, in fact, no force of attraction between its particles. Therefore, there is no definite shape in gas. That's for that. So the next one is definite volume in solid, definite volume in liquid, and no definite volume in gas. Firstly, what's the meaning of the word volume? You see, the amount of space you occupy, that's what we call volume. Look at me now. If I sit like this, I'm occupying more space. It means that the way I am now, I have more volume. Altogether. But if I shrink myself this way, what happen? I'm reducing my volume this way. Are we together? Good. So the amount of volume you occupy, the amount of space you occupy, that's the meaning of the word volume. Now, if I say a substance have definite volume, what does it mean? It means that the volume, the amount of space it occupies do not change. It means that such substance do not expand, it does not shrink. Are we together? Good. If they say definite, it means that it does not change. So look at solid now. They don't expand, they don't shrink. That is, they have a definite amount of space they occupy. Therefore, they have definite volume. That's for solid. Also, same thing as liquid again. They don't expand and they don't shrink. Are we together? They don't expand and they don't shrink. So they have a definite volume. If I put liquid of 5 liter into a 5 liter can, it will still remain that same 5 liter. Are we together? It does not expand, it does not shrink. But gases, no. Gases can expand, they can go far apart. Also, they can also shrink. That is why gases, you can compress them. They have large spaces between one another. Okay, so that's that for that. Next, let's look at the type of motion they exhibit. Vibrational motion, that is for solid. Remember, they just vibrate between each other and it is not what you can see. Liquid can, you see this stationary motion here, it has like, liquid can move, they can also exhibit vibrational motion, they can move from one point to another, they can, they can rotate, they can do a lot of stuff. Are you there? But specifically, we say they exhibit what translational motion, that is motion from one point to another. That's what we call translational motion. Therefore, gases move randomly with no specified direction. As they move randomly, they strike each other and also the walls of the container. Now, here, gases and solid are incompressible. If they ask you to explain this, why are they incompressible? Why? Because they are tightly packed. Because they have large cohesive force between their particles. That's it. But liquid also incompressible. That is, they don't have large spaces between their particles. But gases has large spaces between their particles. That is why they can be compressed. That is that for that. Now, let's look at the change of state. We all know we have 3 states of matter: solid, liquid, and gas. It is possible for a substance to exist in these 3 states. Now, let's look at from solid to liquid state. Now, when a substance goes from solid to liquid, that process is called melting. The process at which a substance changes from solid to liquid. Good. You see, what happens here? You see, when you increase the temperature of a substance, of a solid substance, or you apply heat to it, what happens? The particles will start what? Will start breaking up. Remember that was solid have particles that are tightly packed. So when you continue apply heat to them, what happens? You are increasing the kinetic energy of those particles, and what happens? They will begin to move apart, and it will get to a point whereby you will increase the temperature up to a point whereby the solid particles will finally break up to liquid particle, and that process is called melting. Altogether, the temperature at which solid changes to what? To liquid, and that is what we call what? Melting point. Now, let's look at when liquid changes to gas. What happens? Remember, when you continue heating up liquid, it will get to a point whereby what? Vapor will start building up. Are you there? That is, gases will start what? Will start building up. And what happen? They'll start what? Escaping. All together, and that is what we call what? Evaporation. They'll start what? Escaping. Evaporation don't have any specific temperature it occurs. Evaporation can occur at any temperature, but the one that has a particular temperature it occurs is what we call what? Boiling. But we'll get there later. Now, so just think that from solid to liquid, that is what? Melting. This process can convert solid to liquid. Also, liquid to gas, that is evaporation. Now, what happens if liquid is turned back to solid? What happens? That is what? Freezing. Let me give you an example. If you have water and you place it in fridge, water is liquid. It will get to a point whereby when you change to ice block, that is solid. The process that happened there is what we call what? Freezing. Okay, and that occurs at freezing point. Remember, the freezing point of water is what? 0 degrees Celsius. Next, we have gas to liquid, and that is called what? Condensation. All these are just word and opposite. Remember, when liquid are escaping at the top of a liquid, like when vapor are escaping at the top of a liquid, what happens? That is evaporation. Now, when they are returning back, that is what we call condensation. Are you there? That is when those gases are trapped and they turn back to liquid. That is what we call what? Condensation. So just keep in mind that gas to liquid is condensation. That is it. Now, there are some solid substances that don't exist in liquid state. Let me give you some of them that we use majorly at home. Look at camphor. The one used to chase cockroach in your cupboard. Camphor cannot exist as liquid. It's from solid directly to gas. This type of solid is called a sublime solid. This sublime is gotten from this sublimation, which means that the change of solid directly to gas without passing through the liquid state. That is called sublimation. Also, we have dry ice. Are you there? Dry ice. All these are sublime solid. We have naphthalene. Are you there? All these are they are sublime solid. They don't exist in liquid state. And the opposite of sublimation is what? Is deposition. It will get to a point whereby if you trap some gases and you get them cooled down, they will deposit back solid for you, and that is what we call what? Deposition. So that is that on that. So in the next slide, we'll move deeper into this concept. Now, let's study the vapor pressure in this video. Now, let's look at the vapor pressure. Now, this is the pressure exerted by the molecules of a liquid during evaporation, which causes molecules to collide with each other and the walls of the container. Now, pay attention. Let's assume that we have a container filled with liquid. Now, take note that evaporation occurs in this liquid. That is, some of the molecules escape. Some of the molecules at the surface of the liquid escape. And that is what we call evaporation, right? Take note that what? As the molecule escape from the top of the liquid, they collide with each other. Also, they collide with the walls of the container. And take note that as collision occur, are you there? As collision occur, take note that what? These particles are going to exert pressure on each other and also on the walls of the container. Now, the pressure exerted by this vapor during this evaporation is what we refer to as vapor pressure. Now, let us now look at this container here. We have a container filled with what? With liquid. And here, let's assume that what we are applying it. And take note that what, as it is being applied here, what happens? Some of the molecule will tend to what? To escape from the top of this liquid. And what happens? They'll keep on escaping. And evaporation is occurring. Are we together? Now, it will get to a point whereby this vapor escaping from the top of this liquid, we tend to what? We tend to build up. And when they build up, opposite of evaporation will take place. That is, they will fall back into the liquid. Hold on. When evaporation occurs, they leave the surface of the liquid. When they build up, they lose energy and fall back into the what? Into the liquid. And that is what we call what? Condensation. Now, it will get to a point whereby the liquid and the vapor will exist in what we call dynamic equilibrium. That is, the rate at which evaporation occurs and the rate at which condensation occurs will be equal. That is, observe, if I have liquid, these are liquid particles, and we have the what? The vapor. That is, the rate at which evaporation occurs. This is evaporation. and the rate at which condensation occur will be what? Will be equal. Now, the point whereby the rate of evaporation and the rate of condensation occur is what we call what? The dynamic equilibrium between the liquid and the vapor. And the type of pressure the vapor will be exerting at this dynamic equilibrium is what we refer to as what? Saturated vapor pressure. Pay attention that, you see, when the liquid particle build up at the top of the liquid, they lose energy and fall back. That is condensation. So evaporation occur, condensation occur, evaporation occur, condensation occur. It will get to a point whereby what the rate at which liquid is leaving is equal to the rate at which liquid is falling back. It is equal to the rate at which vapor is falling back into the liquid, and that is dynamic equilibrium between the liquid and the vapor. And the type of pressure being exerted by the vapor in this dynamic equilibrium is what we call what? The saturated vapor pressure. And the point at which the saturated vapor pressure is equal to the what? Is equal to the external atmospheric pressure. You see, this point is what we call what? Boiling point. At that point, we say that what? Liquid is boiling. So if they ask you to define boiling, it is the process by which what? The SVP, the saturated vapor pressure, is equal to the what? The external atmospheric pressure. So the temperature at which this occur, at which this is equal to this, is what we call what? The boiling point. So that is that for that. Thanks for watching this section.